those.
네, 여러분 인공지능 분야의 세계적 권위자 아니마 아난드쿠마르 연사에게 다시 한번 박수 부탁드립니다.
안녕하세요. What a time to be alive. As an AI researcher who's been working in this field for about 2 decades, it's such an exciting time. To see AI go from theory and ideas to one that touches millions of lives in products consumed by millions. So where are we with AI today? And I'm also so excited to come back to Korea after the pandemic. I had talked about AI here about 4 years ago and talked about the exciting developments. But since then, we've seen so much more progress. So AI today is in the era of generative AI. You can go to ChatGPT, ask it to tell a joke, write a poem, even write software code for you. You can go to image models such as Stable Diffusion, ask it to generate all kinds of images. We're also designing new drugs with AI, even predicting what will happen with the pandemic. So much we can do with generative AI today. So what makes generative AI so special? If you think about the AI that's been around for the past decade, it's what I call discriminative AI. It's AI where, given an image, such as the flower here, it would tell you that it's a flower. Right? So you're asking the AI model just to tell you what the image is about, rather than generating the image itself. And that's what we are able to do now. So I call discriminative AI as the inverse process of generative AI. And here we are in the realm of generative AI today. So let's look at text models or language models. These are perhaps the most popular ones today. When ChatGPT came about, millions of people around the world used it immediately and saw its power. But how are these models trained? What makes these models so capable? In fact, the idea behind training these models is quite simple. What we do is take large amounts of text, mostly taken from the internet, and then teach the model how to predict the next word. It's as simple as that. The model looks at all different ways you can complete a sentence based on the data available, and based on that learns the probabilities of how likely different words are to occur. But training this at large scale makes the model possible to actually learn the underlying meaning of the words. And that's how the model becomes highly capable. And after that, you need one more step. So after what we call pre-training, we add an alignment. So what is alignment? If anyone has had a dog or a pet, training the dog means you're rewarding it if it learns good skills. Right? So you say you're happy, you give it a toy or some food when it performs a task according to your expectations. So we effectively do the same with the AI models itself. We give it a thumbs up whenever it aligns with the human preferences, and that's how the language model learns to understand the instructions from humans and respond accordingly in terms of preferences of humans. So that's the overall high-level view of how language models are trained, but it's the large-scale training. So the large-scale data with large number of parameters that makes these models so highly capable. Okay, we have these language models. What do we do with them? Of course, we can generate text, like maybe many of you are doing. But is there something more meaningful and useful we can do? So this is what we went about asking, and we looked into designing AI agents based on these language models. So what can these agents do? These agents can talk to these language models, interactively get help from language models, and then perform all kinds of different tasks and complete them in different environments. As an example of this, we showed how to make it work and learn to play Minecraft. I don't know how many of you here play Minecraft or other video games. Minecraft is quite a special game because it's open-ended, right? There isn't one goal or one way to complete the game. You can keep building new castles, slaying dragons, acquiring all kinds of different skills. And what was impressive was to show that an AI agent could autonomously play this game with the help of language models. So the language models would help it make the next move in the environment, in the Minecraft environment, and come back and get feedback and continuously learn to play and acquire new skills. So this is what we call lifelong learning, learning that never stops. And we can enable that with the use of language models and build AI agents that can interactively query language models and play games like Minecraft. What else can these language models do? Why stop at just the virtual world of games? We can put a physical structure into the language models. Meaning, let's give a body to the mind of language models. A healthy mind in a healthy body, right? And that's what we did with the use of language models to solve all kinds of robotic tasks. In this example, what we did was to show how we can have robots pick and place with all kinds of different text commands by combining language models with a simulator for robotic tasks. And to me, this potential is immense for the use of robotics in all kinds of industrial plants. Right now, robotics is quite rigid there because it's already pre-programmed to complete one task. On the other hand, with the use of language models, we can make it a lot more flexible, adaptive, do new tasks in a zero-shot manner. What else can we do with language models? So far, I talked to you about natural language, meaning models like ChatGPT that understand English or other models that understand Korean and other languages. But why just stop at natural languages? Why not look into the language of life itself? That is our DNA, right? That is our genome. And that's what we did in another project. We took all the genomes of known bacteria and viruses and trained now a new language model to predict what will come next in the genome, in the sequence that it makes up the genome. And once we trained this, we could then ask, can you generate new genomes? Meaning, can you predict now new mutations of different bacteria and viruses? And given that we did over the last few years, where the pandemic, of course, has been such a big issue all over the globe, we wanted to focus it on the coronavirus. We asked this model, can you now predict new variants of concern that haven't yet emerged? And with that, can we design better drugs and vaccines even before new mutations occur or even new pandemics occur? And what you will see in this visualization is during training, we showed the model only the variants that appeared in the first year, meaning the alpha and beta variants that appeared in the first year of the pandemic. We didn't tell it any of the other variants, but it was able to automatically generate the variants that emerged later, such as the Delta and Omicron. And in the latent space of the model, it's nicely clustered where the different variants are, meaning it has a good organization of different mutations, which ones are closer to one another compared to others. So this, I think, is really great because with this, we can be better prepared for future pandemics. We can be better prepared with the design of drugs and vaccines with the use of genome-scale language model. So what else can we learn with AI? As I mentioned, the genome-scale language model will tell us new genomes of possible mutations of virus, such as the coronavirus. But then, in order to determine, is that really a dangerous mutation, right? Is that going to be the one that we should be concerned about? We need something more. We can't just look at the genome. We have to ask, what will this new mutations do in terms of binding to protein and other targets in our human body, right? So how well can it infect us? And these ones are governed by laws of physics. In fact, you need to look at how these different molecules bind to one another, and that can involve even effects at the quantum level. And it's extremely expensive to simulate this with current numerical simulations. And that's the case with so many other natural processes. For instance, we can ask about predicting the weather tomorrow or over the next few days. In order to do that, you need to understand the complex processes that happen around the planet. How do the storms form? How is the cloud turbulence? All of these different factors impact the weather. And given data, can AI learn this? Can AI learn these processes that occur at many different scales? You have precipitation at what we call the micro scale. And then we have other effects that happen at higher spatial resolutions. And all of this come together to determine the weather on this planet. And what can AI do here? AI is significantly faster compared to traditional numerical simulations for many of these domains, such as understanding molecular binding or weather forecasting. Why is that? Because AI builds on all the hardware and software breakthroughs we've seen over the last few decades, right? So the Moore's law is slowing down. And with the use of accelerated computing, such as GPUs, we are able to achieve the parallelism and much better computing efficiency. And on top of it, incorporating software frameworks and algorithmic frameworks, such as mixed precision, we can run AI models at much reduced precision compared to other scenarios, other traditional numerical simulations. And combining all this allows machine learning to take advantage of hardware and software efficiencies and also learn better features from data itself. And here we are able to show that we can do accurate weather forecasting while being tens of thousands of times faster. And not only that, it is now running on ECMWF website, which is the premier weather agencies. You can all go download this model, run it on your local desktop, and get accurate weather predictions. And further, you could fine-tune the model for the region here and get even more accurate predictions for Korea. And that's what we've done. We've democratized and made these models available, and they're much cheaper and faster to run than traditional models. And along with it comes the ability to do extreme weather predictions effectively. Meaning, like hurricanes, it's impossible to predict where exactly the hurricane will land, because it's what we call a chaotic event. On the other hand, with cheap AI forecasts, we can perturb and look at different scenarios and come up with an overall risk assessment of how likely is the hurricane to hit the coast of Florida, as this example here. So what else can AI do in terms of handling this climate change? AI can also help mitigate climate change. One aspect is, how do we get to net zero? Meaning we have to capture carbon dioxide in different ways and maybe store them underground. In the next visualization, what you will see is how carbon dioxide can be pumped underground into reservoirs with water, and we can accurately predict what would be the pressure buildup. As you keep pumping carbon dioxide, how does the pressure build up? And how does the carbon dioxide gas change or move over several decades, so that we want to make sure they're still trapped underground and not released to the atmosphere. AI can do this about 700,000 times faster than traditional simulations. And it allows us to prepare for climate change mitigation and plan this at a large scale. And we can also use AI in so many other frameworks. So the previous examples I showed you on weather forecasting, carbon capture and storage, used an AI model called neural operator. Think of it as extending the language models to now continuous multi-scale processes. So that's the framework we design, and it's also useful in so many other simulations. For instance, nuclear fusion, if we can achieve it, oh my God, that would be amazing, right? So if we can handle the problem of disruption, predicting disruption would really enable us to make it sustainable. And that's what we're able to do with AI, predict disruptions before they happen in nuclear fusion. With ultrasound imaging, we can really make advances in real-time imaging, which is non-invasive and can really help us detect cancers early on and many other diseases. And AI can not only simulate, it can also design. We came up with an optimal design of a medical device called catheter, and we designed these triangular shapes to help prevent bacteria swimming into the patient's body when there is fluid flow, and with that, reduce bacterial contamination. AI is also helping in mask design in lithography, which is one of the key steps in the chip manufacturing process. So as you saw, there is so much AI can do that is positive and highly beneficial to the society. But of course, as with any technology, there are risks in addition to these positive benefits. So how do we deal with this in a balanced way? So we need to think about trust. Trust is so important when we deploy AI in real-world systems. And to me, a trustworthy AI is one where we have transparency and accountability. Can we really test these systems and understand the failure modes? Because these AI systems fail in very non-intuitive ways, not in the same ways that humans fail. And so we need to understand how those errors are made and how we can mitigate them through other strategies. In addition, we need to be worried about the societal bias that may be present in these models due to the imbalanced data that are used for training. And this is so important because we don't want to stop the technological progress, right? We really want to be part of it, and we want to use that for all the positive benefits. And as we look at a trustworthy AI design in a holistic manner, I think we can achieve all this very well. So how should industry leaders think about the use of AI, and how should they prepare for AI? I think it's very important for industry leaders to not just be aware of AI, but to really nurture AI talent in-house. Of course, the actual size of it may depend on the company, but it's important to plan for the long term, because AI is not going away, right? It's not a fad. It's not something you just do it once and you're done. It's something you plan for the long term, and you also want to be pragmatic and prototype and quickly run them in the workflows. So not just put AI separately in a vacuum, but really make it part of any workflow that you're using. At NVIDIA, we recently announced Chip Nemo. So there, we are able to use the power of language models and train it to help with chip design and testing. And so that's something that is really important. And so every business has to ask, what is important for me? What are my use cases? And make sure to adapt AI for that rather than treat it as a hammer in a more blind way. Ultimately, we need to think of AI not as a competition to humans, but really as a collaboration. The long term will be bright when AI and humans can work together seamlessly. As an example, I'm working with a robotic surgeon to help use AI to guide the surgery process, but not to take away that expert surgeon, because AI is still a long way from being able to do this in a trustworthy manner and in a safe manner. But together, we can do all this very well. I think the future is bright, and thank you for having me here. Gamsamida. Yeah.